We are from Group 13 from Session 5, and our project title is Door Security System using FSM and DataPad in Verilog HDL. First, I will introduce our project overview. The objective of this project is to design and verify a Verilog HDL door security system where the control unit CU manages the system state, while the DataPad unit perform the important operations such as password compilation, timer countdown, and also the failed attempt counting. The type of authentication in this project is divided into two types, which is password or the Face ID authentication. The DataPad handles the password checking, timer, and attempt counter, and the door lock unlocks only after the authentication success. However, the alarm will activate when the tamper is detected or the authentication is failed for several times. Next, I would like to explain the details of design concept. For design concept, our system is divided into the two main parts, which is CU and DU. First, the control unit CU is designed as a finite state machine, FSM and E control as shown in this slide, and the control unit receives input and status signals that generate control units such as the control unit receives input and status signal then generates the control output such as the timer EM, INC attempt, clear attempt, door lock, and alarm. While for the DataPad unit, the main function is used to password completer, failed attempt counter, timer counter, attempt limit checker, and also the timer dump checker. For the DataPad unit, the important status signal sent to the control unit such as the password correct, timer dump, and also the attempt limit. Next, this slide shows the top-level system module in our door lock security system, and the complete system is divided into a controller and a DataPad unit. For the top module, the door lock system connects all external signal with the control unit and the DataPad unit. And in this module, the external input has allowed the system to detect whether the door lock is armed, whether the door lock sensor is triggered, tampering occurs, or which authentication method is selected. Besides that, the main outputs in this project are used to show the system response and also help us to monitor the simulation result. In overall, this top-level system model shows how all signals are connected together so that the CU and DU can work as a one complete door lock security system.
Okay, so now this is the coding for the CU part. You can see here we have the select with the two segment, which is the step register in the one segment, and another segment is the next step and the output logic. So for step register, you can see if there is a reset button is activated, the step will come back with the either step, else the step will go to the next step. The either step is about the state 0. So now we will go through to see one by one, which is the content of the stage. For the either stage, this is the waiting stage. We need to wait for the information. So if there is the temper sensor is activated, the next step will directly go to the alarm SD stage, which is the last step. Else, if the system arm and the door sensor has been activated, the next step will go to the trigger step. Else, the next step will go come back with the either step. So in the trigger step, because the door sensor has been activated, the trigger step will go to that trigger step, and this is just for pass-through step. The next step will directly go to the web automation step. For the web automation step, the timer does not count here, does not activate here. If the temper sensor has been activated in this stage, the next step will also goes to the alarm step as well. Else, if the auto select is once, it will go to the Face ID check. Else, it will go to the password checking. So now we will start to see with the password checking. In the password checking and also with the face checking, the face checking and also the password checking here, the time count will start to count now. So now we go through with the face checking. If there is the temper sensor activate here, the next step will also go to the alarm step. Else, if the timer stun has been done, the next step will go to the field because you have not insert anything yet. But if your face check and the flash is matched, the next step will go to the SS stage. But if your flash has been checked, it's already reached the time, but your face is no match, it will go to the field stage. Otherwise, it will come back with the face checking step. Since go with the password checking stage. For the SS stage, the door will be unlocked and it will kill the attempt counter. If the door is closed, the next step will come back with the either step. Otherwise, it will go to the SS stage. So now we can see for the field stage, the increased attempt will activate. That means we will increase the attempt. So if there is reach the attention limit, the next stage will go to the alarm SD stage. What is the number of the attention limit? It will go through with the DU letter. So now we will go to the alarm stage. For the alarm stage, the alarm will be activated and the door lock will be activated. It will be activated until the door reset has been put into the ones. So this is for the CU code. And the test we have undergo the several tests which include with the correct password, wrong password, password timer timeout, correct face ID, wrong face ID timer timeout. The attempt limit goes to the alarm reset, and also the temper sensor from the either. So now we can run with the process. You can see this work here, and if I want to see with the waveform, so it will show the waveform starting here. Okay, so now we've done adjust with the waveform. So now we can see the waveform has been set clearly. So now we go through with the step one by one. For the test one, we verify the correct password authentication process. So the system will start with the either step. You can see it here, start with the either step. So when the system is armed and the door sensor is triggered, you can see here is anywhere. The FSM will move to the either step to the trigger, which is the step 2 and step 1, sorry. So in the step 1, it will wait for the authentication process. So since the authentication is a password, so we can now see that it will go through with the password checking. In the test, the password enter and the password collect are both 1. You can see here. So the meanings the user has entered the correct password. Therefore, the FSM will move to the SS step. In the SS step, the dollar output becomes 0. You can see the dollar output becomes 0, and also, which means the door is unlocked. The kill attempt signal is also activated to kill the attempt counter. When the door cross becomes the 1, the system will return to the either step. Okay. The system did show the correct password path is working properly. So in the test 2, we verify the wrong password conditions. The FSM again start from the either and move to the trigger step to detect when the ARM system detect the door sensor. Then it move to the web authentication and enter the password checking because the password authentication is selected. So you can see here. In this test, the password enter is 1 and the password collect is 0, meaning the user has entered an incorrect password. So as a result, the FSM will move to the field step. You can see here, the password collect is 1 and the password enter is 1 and password collect is 0, so it will go through with the field step. So in the field step, the increased attempt signal becomes 1, which increases the wrong attempt counter. Since the attempt limit is still 0, the FSM does not enter alarm step and instead it turns to trigger to allow another authentication attempts. The web phone shows the retry behavior clearly, and so the test is correct. So now we go through the test tree. We verify the timeout condition during the password checking. After the system is armed and the door sensor is triggered, the FSM will move to the either to trigger. You can see here, move to the either to the trigger. And then to the web automation, and finally to the password checking. In this test, the password enter remains 0, meaning the user has not entered any password yet. While the FSM in the password checking, the timer enable signal is activated. You can see here. So it means allow the authentication time has been added. So therefore, the FSM move from the password check to the field step. In the field step, increase attempt is activated to increase the attempt counter. This confirms the password timeout function is working correctly. So now we go to the test 4, which is the collect face ID. Same go with the previous step. So now we let's go to the web automation. It will activate to the ones. Auto select it is 1. That means it will go through with the face checking. So you can see the face check is 1 and the face match is also 1, meaning the face checking process is complete and the face match with the stored identity. So it will go through with the SS dash, and the SS dash will same goes with the previous dash. So now we go to the test 7, which is attempt limits goes to the alarm. In the test 7, we verify that the FSM enter the alarm step when the attempt limit is reached. This allow the system allow the password authentication path by moving from either to trigger, then to the web authentication, and then password checking. In this test, the password check is 1, and the password collect is 0 as stated here. So the password is wrong. Therefore, the FSM will move to the field stage. But you can see at the field step in here, the attempt limit is set to 1, which means the maximum number of wrong attempts has been reached. Because of this, the FSM moved from the field step to the alarm ST stage. In the alarm ST stage, you can see it here. The alarm ST stage, the alarm output become 1 and the door lock remains 1, meaning the alarm is turned on and the door stay locked. This shows the attempt limit protection is worked correctly. Now we go through with the last stage, which is the alarm reset. Sorry. Is the last 2 steps test. The alarm reset, we verify the alarm reset function. The test starts from after the FSM has already entered the alarm ST stage from the previous test. In the alarm state, the alarm signal is 1. And the door remains locked. When the alarm reset is set to 1, the FSM assists the alarm ST stage and return to the either. At the same time, the kill attempt signal is activated to kill the wrong attempt counter. So now we can move to the last test, which is the temper sensor for the either. You can see that for the either stage, if the temper sensor has been activated, it will directly go to the alarm step. Yeah. So that's all for my present.
In this part, I will explain the Verilog test and simulation output for our data path unit. And the data path unit we use in our door security systems, its main job is to handle the data processing part of the system. In this design, the performs 3 main functions, which is the password checkings, attempt counter, and the authentication timing. First, I will explain the Verilog code. The data path unit Verilog code have several input, which are clock, reset, password in, INC attempts, clear attempts, and also the timer enabled. So the clock signal is used to control when the counter is the timer update, and the reset signal is used to return the system to the initial condition, and the password in is the 4-bit password entered by the user. The INC attempt signal is used to increase the attempt counts when the password wrong, and the clear attempt signal is used to clear the attempt counter, and the timer enable is used to start the timer. This module also have 3 output, which is the timer count, timer attempt count, and also the correct password. And in this code, the stored password is set as the 1010, and the maximum attempts is stored as 3, and the alternation time is set as 6. So this means that if the users enter the 1010, the signer's password correct will become 1. If the user enter any other values, the signal will become 0. So for the INC attempt is high at the positive of the counter increased by 1. In the simulations after 3 pulse, the counter increased from 0 to 1, then 2, and finally go to 3. And also for the alternation time. And now move on to the test banks, and the purpose of the test bank is used to test whether the data path works correctly. It gives different input to the data path and check the output result. The test bank first generate a clock signal, and before the test bank is clear all the input and reset the system. This make sure the simulation start from the no conditions, and after reset the attempt count start from 0 and the timer start from 6. There are 5 test cases in the test bank, which is the first one 1010, and you can see that the password ins at the test one is 1010, which means that the password correct will become 1, and this also proves that our data path can detect the correct password. And for the test 2, for the wrong password detect, we first give the password as 1111, and you can see that the password correct will become 0, and this means that it can detect the correct password and the wrong password. And also for the test 3, the attempt count, the test bank activate the INT attempts 3 times. Each pulse represents 1 wrong password attempts. For the output, we can see that the attempt counts increase from 0 to 1, then 2, and then 3. This confirms that the attempt count is working correctly. And also for the test 4, the clear attempt counter, and we map the clear attempts at once, and you will see that the attempt counter will reset to 0 after the clear attempt is activated. And next is for the alternation timers, and when the timer enable becomes 1, the timer will start to count down from 6, and also this shows that our timer is work correctly. And not only that, we also can see the output more clearly at the EPWF, and you can see that for the S5, the counter is start from 6, then 5, 4, 3, 2, 1 to 0. And when reach 0, the timer downs will become 1 to show that the timer already done the countdown. This part I will briefly explain the complete download system simulations. Since the control system and the data path unit have already been explained separately, so in this part mainly show how both units are combined together in the top module, which is the download system. In these top modules, the control units generate control signals such as the INC attempts, clear attempts, and the timer enable. These signals are sent to the data path unit, and the data path unit then performs password checkings, attempts countings, and the timer countings. After that, it sends the result back to the control unit through the signals such as the password correct, attempt limit, and the timer down. So the control unit is responsible for deciding the system state, while the data path unit will provide the data result need for the decisions. For the test banks, we decided to 9 test sets to verify the complete download systems. The tests include the correct password, wrong password, password time out, and correct face IDs, wrong face IDs time out, and attempts limit go to, alarm reset, and the last one is the temper sensor from idiot. And for the simulations output, we can observe the state transitions, password result, attempts counts, time counters, and also the door lock output and the alarm output. When the authentication is correct, the system enters the access state and unlock the door. When the password or the face ID is wrong, the system go to the fail state and increase the attempt counter. If no valid authentication is received before the timer ends, the system will also go to the fail state. When the attempt limit is reached, the system enter the alarm state. The alarm can be cleared using the alarm reset signals. Lastly, when the temper sensor is triggered, the system immediately enter the alarm state. In conclusion, the simulations provide the combined control unit and data path unit can work together correctly. The complete system can be handle password, authentications, face ID, authentications, tie up, fails, attempts, alarm reset, and also the temper detections. Thank you.
Our door security system is successfully designed using the FSN plus data path. The control unit match the system stack, and the data path unit can handle the password comparison, field attempt counting, and the timer countdown. And our simulation result have proved some of the things, which is the correct authentication unlock the door, wrong authentication or time out increase the field attempts, temper detection and attempt limit activate the alarm, and also the alarm reset return the system to leader. So overall, the system achieved the objective of the functional digital download system using the value HDL. Okay, so thank you.